Hi, welcome back. So, in this session, we're going to start by having a discussion about the flavors of Python. So, in Python, flavors typically refers to different versions or implementations of the language. Each flavor has its own unique features and characteristics, but they all share the same core language and can run the same Python code. So, let's talk about the different flavors in Python. The most common implementation of Python is CPython, which is written in C and is the reference implementation of the language. It is the standard flavor of Python. It can basically be used to work with C language applications as well. Second is Jython or JPython. It's used for Java application, and its implementation of Python is that it runs on a Java virtual machine as well. While IronPython is an implementation of Python for the .NET framework. The main advantage of the PyPy flavor is that the performance will be improved because it has a JIT compiler which is available inside the Python virtual machine. JIT basically stands for your just-in-time compiler. Alright. Then comes Ruby Python, which as the name suggests is for Ruby platforms. And lastly, Anaconda Python, which is specially designed for handling large volumes of data processing. Apart from these, there are many different flavors in Python, but these are just some to name a few. Moving on, we also have to discuss what is a Python virtual machine. We've already had a discussion that Python is what? An object-oriented programming language, just like Java, but is also called an interpreted language. Now, what happens under the hood of Python is that Python actually uses code modules that are interchangeable instead of a single long list of instructions that is actually a standard for functional programming languages. The standard implementation of Python is called CPython, like we mentioned, but what we need to understand here is how a Python program works. Python doesn't convert its code into machine code, which is something that a hardware can understand. What it actually does is it converts it into something called bytecode. So what happens is within Python, compilation does happen, but it's just not into machine language. It's into bytecode. All right. And this bytecode cannot be understood by a CPU. So we need an interpreter called the Python virtual machine to execute the bytecodes. So let's understand how this works. One, when you start writing a Python program and you actually write a code, which is your source code or instruction, the compiler actually does the job of reading your code. It verifies whether the instruction is well formatted, if you followed all the rules, and it checks the rules of your language and checks the syntax of each line of your code. If any problem occurs or if it encounters an error, it immediately halts the translation and shows an error message. But if there was no error, this Python instruction or source code that you've written will then be used by the compiler to translate it into something known as bytecode. This bytecode is then sent to the Python virtual machine, which is the PVM, and which is also known as the Python interpreter. If you need any external libraries, then those libraries are also interpreted and imported by the Python virtual machine, after which the Python virtual machine converts these bytecodes into a machine executable code, which basically gives you an output. Obviously, in the Python virtual machine step, if any error occurs during the interpretation, the conversion is halted and an error message is given. After this, we'll now get into a discussion of what is a frozen binary. Now, when you write a Python program, you obviously must be writing it for somebody or for a client. Now, when you have to give that client your program, you are obviously not going to send them the source code, right? Because when sometimes people ask for a real Python compiler, what they're actually seeking is a simple way to just generate an executable file from your Python program. Using some third-party apps and tools, you can actually take your Python program and turn it into an executable file, because you will not really provide your source code. What you will rather provide to your client is an exe file which they can just double click and install everything that they need so that they can work with your application. That's what a frozen binary is called in the Python world. Basically, when you write a Python program, this is the structure that we've just discussed, that you have a source code, you pass it through the compiler, it becomes a bytecode, then goes into your Python virtual machine where all the libraries are imported and an output is given. A client may or may not be technically sound and they may or may not know how to work with Python. So you cannot obviously provide your source code to the client. At the same time, if you do provide your source code, you will have to ask them to install Python, import libraries, and so on, which is something that a client may or may not be able to do. Obviously, you want to provide convenience to your client, right? So what we would do is we would actually use some third-party tools. The tools that we actually use, one of them is called py2exe, which is a pretty famous tool used to convert your Python program to an exe file. These tools will then take your entire compiler, Python virtual machine, and whatever external files and libraries are required and convert them into an executable file. This executable file is what you will provide to your client, which helps them in then installing the application like you would install any software in your system. And that is what a frozen binary is. Frozen binary is the conversion of your Python program into an executable file. Moving on to memory management. When you write a program, where is the program stored and executed in your system? Whenever you save your program into any kind of file, let's say it's a random file, whatever it may be, like random.py, this file automatically gets stored in the secondary storage, which is basically your hard disk. The operating system's kernel, which is your kernel's file management system, does the job of actually storing it there. Basically, understanding your memory allocation is important, as you, the developer, will be able to write a more efficient code. And when we say that a code is efficient, we basically mean that the code is memory efficient. What can memory allocation be defined as? Basically, it's defined as allocating a block of space in your computer memory to a program. In Python, memory allocation and deallocation method is automatic, as the developers of the programming language created something called as a garbage collector for Python so that the user does not have to do any manual garbage collection. So when we run a program, it is actually loaded into the main memory or the primary memory of the computer called the RAM. The entire program is transferred to the RAM, and we know that in this there are two types of memory there, the stack and the heap. But the stack basically is a special area in your computer's memory which stores your temporary variables created by your function. In a stack, your variables are declared, they are stored, they are initialized during the runtime. The allocation happens on a contiguous block of memory. The size of the memory to be allocated is known by the compiler, and whenever a function is called, its variable gets memory allocated on the stack. It's a temporary memory, so when the computing task is complete, the memory of the variable will automatically be erased. The stack section contains all your methods, local variables, and your reference variables. All right. The allocation on the block of memory is completely handled by the compiler, so you as the developer do not have to worry about how it happens. The second type, like I said, was heap. The memory that is allocated during the execution of instructions written by the programmers is done in the heap. The name heap has nothing to do with a heap data structure. In this case, it's called a heap because it's like a pile of memory space available to a programmer so that they can allocate and deallocate items in there. The heap is basically like a memory used by the programming language to store all your global variables. If you're not aware of what a global variable is, we are going to be having a discussion and knowing what a global variable is in our variables module. But by default, all global variables are stored in the heap memory space. It also supports dynamic memory allocation as discussed before, and the heap is not managed automatically for you, and it is not as tightly managed by the CPU. So it's more like a free floating region of the memory. So in summary, the variables that are needed outside of a method or a function call and are shared with multiple functions globally are stored in the heap memory. All right. And this is kind of what they look like. So that's the difference between stack and heap and how the stack and heap memory is used in a Python program. Knowing what memory is used will actually help you write a more performant code. Moving on, we now have a discussion about the differences between C and Python. We start by having a discussion about their usages. When it comes to C, C is generally used for hardware related applications, whereas Python is a general purpose programming language. When we talk about the type of programming, C follows an imperative programming model, whereas Python follows an object oriented programming structure, which makes use of classes and objects. When it comes to the usage of pointers, there are pointers which are available in C, however, they are not available or there's no pointer functionality available in Python. The way it is compiled or executed in C is that C is a compiled language, whereas Python is an interpreted language. In C, the entire code is compiled and then executed, whereas in Python, the execution occurs line by line. However, when it comes to the number of built in functions, there are only a limited number of built in functions in C, whereas there's a large library of built in functions when it comes to Python. However, when we talk about the speed of execution, in C, the code is much faster because it is compiled, whereas in Python, it's kind of slow because Python has garbage collection as well, as we've discussed in memory allocation. All right. Then, when it comes to the implementation of data structures, its functions actually need to be explicitly implemented when it comes to C, whereas in Python, it gives us easy implementation of the data because the structures are built in with some functions like insert and append, as you will be seeing when we get into the main course. Then, when we talk about the variable declaration, it's absolutely compulsory for you to declare the data type of the variable in C, whereas Python is a dynamically typed language, so you don't really need to declare the type of variable. It will happen during your runtime. Lastly, when we talk about the syntax of the programming language, the C programming language has a hard syntax, whereas when you see the syntax of Python, you'll realize that it's absolutely easy to work with the Python programming language. In the same way, let's also have a comparison between Python and Java, since we've already discussed Python and C. We start by having a discussion about the differences in their code. When you write a program in Python, a Python program has lesser lines of code, whereas Java programs have longer lines of codes. When it comes to the frameworks in Java, the number of frameworks that are there are really large. You have popular frameworks like Spring, Hibernate, etc. Whereas when it comes to Python, it has a lower number of frameworks as compared to Java. But the popular ones are Django and Flask. All right. Moving on to the syntax of the programming languages. The syntax is complex in Java as it may and will throw an error if you especially miss a semicolon or curly braces. Whereas in Python, the syntax is easy to remember because it's almost similar to human language. The key features is that Java has self-memory management, it's robust, and it's platform independent. Whereas when it comes to Python, the key features is that you have lesser lines of code, it's used in rapid deployment and in dynamic typing. The speed of the programs obviously has Java being the faster one as compared to Python, and Python is slower since it uses an interpreter and determines the data type at runtime. Whereas when it comes to databases, the Java database connectivity or the JDBC is most popular and widely used to connect with databases, whereas Python databases access layers are weaker than Java's JDBC. This is why it is rarely used in enterprises. When it comes to the machine learning libraries, in Java you have Veka, Mallet, and Deep Learning 4J, whereas in Python you also have TensorFlow and PyTorch. However, when it comes to the practical agility of the language, Java enjoys more consistent refactoring support than Python, thanks On one hand, to its static type system, which makes it automated, refactored, more predictable and reliable. And on the other hand, to the prevalence of IDEs in Java's development. Whereas when it comes to Python has always had a presence in the agile space and has grown in popularity for many reasons, including the rise of the DevOps movement. And in conclusion, we can say that both Java and Python languages have their own benefits. It really is up to you as to which language you opt to for a particular project. Python is simple and succinct, whereas when it comes to Java, it's quick and more portable. However, when it comes to the future, Python's future is very glaring from where we see it right now, and we can absolutely see Python in the future as an emerging language. And obviously, we have to agree that it's going to be larger than what Java is at present. All right. But that's an introduction into Python programming. In the upcoming lecture, we are going to be having a look at a simple execution of a hello world program. And we'll also have a look at how we can see the bytecode of a program, which is what we had discussed in frozen binaries as well as in PVM. Thank you.